For calculus.
Who would it be?
Okay.
Me.
Lesson 2 is tangent lines and the derivative. I've mentioned the derivative a lot. We're officially talking about the derivative now. Okay? Some of the stuff we're going to do, you're going to be like, oh, we've already been doing that. Yes, we just weren't calling it the derivative yet. Okay? Or officially. Now, two main concepts in calculus known as the tangent line problem, which we've already been working with, right? And I keep telling you that slope of the tangent line is the derivative, right? That's where we're at today. And then eventually later on this semester, next semester, we'll talk about integrals, which those relate to area problems. So area under a curve. Both of these ideas do relate back to limits. We applied the difference quotient here, didn't we? Right? We applied the difference quotient to a function and found a general slope formula. This calculated the slope of a tangent line at any point on the curve, provided the limit exists at that point. Excuse me. This general slope formula is also a function and is called the derivative function of f of x, or f prime of x, which is that little, I don't know what we decided to call it, but it's that prime mark. Looks like a single little apostrophe almost, except it's straight. So a function that has a derivative at a point is said to be differentiable at that point. So that's a vocab word you'll hear me talk about. When we talk about something being differentiable, that means you can take the derivative. So that'll come up more later, but that is going to be a vocabulary word that we will talk about. Okay, we have a box. Boxes are always important, right? Definition of the derivative. This is how we're going to be finding derivatives right now. Okay?
Perfect timing.
Yeah, that was pretty good timing. Okay. Definition of the derivative. This is how we're going to be finding the derivative right now. It's gonna kind of stink. Okay? Because you recognize what we've been doing, right? This is the formula we were already using, that slope definition, the limit definition of the slope. This is what we're going to be doing. This is definition of derivative. Okay? It takes a little bit of work. What I'm going to tell you long term is being able to recognize something in this form is going to be more important than actually using the definition of slope. Okay? So long term, when we look forward to AP, I'll be trying to get you guys to recognize, oh, that is in definition of a derivative. Like that's derivative form. Okay, just take the derivative of that function. But right now, we're using it to learn it. Okay? So derivative of the function f with respect to x is function f prime of x whose value at x is given there. Again, provided the limit exists. Note, the domain of f prime, which consists of all values of x in the domain of f of x, for which the limit exists, may be smaller than the domain of f. If f prime of x exists, we say that f is differentiable at x. Okay? Another thing I can mention, in terms of that notation we talked about earlier, this is the the slope of the tangent line. Okay? So you may see that as well. Now, this chart just talks about proper notation. Many ways to denote derivative, some of the more common ones. F prime of x. Definitely one of the most common ones, easiest to use, right? Or you could do y prime, because we know f of x and y are essentially the same thing, aren't they? So f prime of x, it's a formal name. It names the function and the independent variable. Y prime, it's considered more shorthand. It's brief, but it doesn't tell you what the independent variable is. So it doesn't, where f of x tells you, okay, x is your variable that we're working with, y doesn't say that. Dy dx, okay, or the derivative of y with respect to x, uses d for derivative and names both variables. It's a common one. It's kind of annoying to write, isn't it? Or I guess you don't know that yet, but it's kind of annoying to write. F prime of x is easier, but there are reasons we will need to use dy dx. It is kind of. Df dx, the derivative of f with respect to x, emphasizes just that it's function of f. I'll be honest, we don't usually see df dx. That's the least one. And then d dx of f at x, or the derivative of f at x. So this says take the derivative of f of x with respect to x. We laugh at the fact that I'm tongue-tied here.
No, I like the little comments on this slide.
Oh, okay.
They kind of crack me up.
So, and you guys know, these aren't my comments, so,
Like,
but.
it's just awkward to use.
Yes, I know. That's what I was laughing at.
What? Oh, awkward to use. Well, yeah. Shows the differentiation is an operation performed on f. And the thing is, like dy dx, it says awkward to use, but it is important. And just because it's awkward to use doesn't mean we'll skip using it. Okay? We have to use it. You have to be familiar with it. And there will be times where it will be the advantage. Okay? Okay. I think we're ready to move to the next page.
I have just a question. I don't know if it is gonna relate. It does, because when the question is derive,
Mhm.
is that different, like, from this? Okay, on AP Physics we had a question on the AP test. Derive something from this equation, or like.
That would not be the same as a vocabulary word derivative.
Okay.
No, and I'm trying to think.
Because we asked Mr. Kevin after, and I got like a long spiel that didn't.
I'm trying to think.
Did not help
Derive
me.
something. That's if I have a problem in front of me, I can explain that better. But when I'm thinking, so yeah, derive and derivative. Well, yes, they sound alike. They would have two different meanings in the sense
Okay.
you're looking at. Okay. I'm trying to think. I don't feel like you'll be asked to derive anything and be told let's take the derivative. I don't think.
Okay.
I don't feel like we see that vocabulary.
I've been waiting until we get to this to ask that question. So
Yeah.
I'm very.
I feel like
confident
derive something is more like maybe create the formula or something.
He explained it as like using those formulas we have like on our paper and in our head to take like them all out of that, and so kind of like
Yeah.
branch it out, make it true.
Yeah.
Of all the.
And again, it would be easier if I, saw it. If I have it used in front of me, I could explain it better.
Yeah.
Off the top of my head, I'm fumbling. So, okay. Limit definition of the derivative. Okay, graphically, the derivative of a function at a point P is the slope of the tangent line, right? No surprise there. I keep talking about that. If you don't know that, you've been sleeping during class with your eyes open because I don't know how you wouldn't know that. Okay, so derivative, slope of the tangent line. That's graphically when we look at something. Numerically, the derivative at a point is the limit of the slopes of the secant lines or the limit of the difference quotient. And this is going to be the idea that as h approaches 0. Okay. Verbally, a function f is said to be differentiable at a point if and only if it has a defined slope at x equals a. If a function does not have a tangent at a specified point, the function cannot have a slope there either. So we'll talk about the vocabulary to differentiate. Something is differentiable if you can take the derivative. If you can't take the derivative, or if the derivative doesn't exist at that point, it's not differentiable. And that's kind of what that's referring to there. Okay. Example 1. I feel like this is going to be old news. Use the limit process of the derivative to find the formula dy dx for the derivative of f of x equals 2x squared minus 3x.
So
Go ahead.
we're just using this.
Mm-hmm. So in other words, in order to use, we're going back to this right here. Okay. Notation-wise, what does she throw in here? dy dx. So in order to find dy dx, I'm going to do the limit as h approaches 0 of f of x plus h minus f of x all over h. That's the formula on the previous page, yes? The only difference is that we're working with x's here. You don't see the a plus h in the a. That's the only difference. So we're just sticking with x's. So, are you ready? So dy dx is going to be the limit as h approaches 0, f of x plus h. How am I writing this out to begin with?
2 times x plus h squared minus 3 x plus h.
Okay. 2 times x plus h squared minus 3 times x plus h. So that's just me, and every place I see an x, I'm replacing it with x plus h. Now it's minus f of x, so minus what?
2x squared minus 3x.
Minus the quantity, 2x squared minus 3x. All over h. Sorry, when you guys were complaining about foiling earlier, I'm like, bad day to be complaining about this because I know where we're going. Okay. So, still the limit as h approaches 0. Let's hope some awesome stuff happens here. Okay, we did this the other day. Can we FOIL and then also multiply it 2 at the same time?
Yeah.
I
You have to keep writing b, y, d.
Not necessarily.
Okay.
I mean, we could have also just kind of making things worse, not better. I mean, you could just kind of continue like that. So, you do have to keep writing the limit. Got it?
Right.
Write the limit.
Is it just most important you write the dy dx on the first step?
It needs to be in there somewhere is what I would say. Okay. Okay, guys. X plus h squared and then multiply by 2. First term is going to be
2x squared.
2x squared plus
2xh.
4x.
4xh.
Are we there?
yeah.
Outsides are 1xh. Insides are another xh. So together those are 2xh. And then multiplying by the 2 is 4xh. Plus,
2h squared.
it's h squared multiplying by 2, 2h squared. Then,
Minus 3.
minus 3x minus 3h. Minus 2x squared and plus 3x. And this is where we pray that big things happen, right?
We do. Nothing's happening.
2x squared minus 2x squared minus 3x plus 3x.
And that's it.
That's it, but everybody has an h left, don't they? So that gives me confidence that I didn't mess up. Limit as h approaches 0 of 4xh plus 2h squared minus 3h all over h. And I guess if you wanted to go ahead and factor the h out there as you go, then you can cancel. I guess you guys could do that.
Usually I just cross out all the H's, but like I keep in the back of my mind that I have to do it correctly.
Proper notation is important here, yes. And that's why, as much as I want to just go cross, cross, cross,
Yes.
cross, I try to avoid. Okay. Factoring the h out, we have what?
4x plus 2h minus 3.
So now I can cross those h's. So it's the limit as h approaches 0 of 4x plus 2h minus 3.
Post that 0 in there.
Where does that 0 go in?
H.
H.
It says h approaches 0, so it's going to go in right there, isn't it? And so my limit's going to become
4x minus
4x plus 2 times 0 minus 3 becomes 4x minus 3. So all of that to say that dy dx is equal to 4x minus 3. Okay, that's it.
That's
So
so much
what-
easier now.
Why is that so much easier now? Just because we've practiced more? Because it's no different than what you were doing in homework last night.
Do you dx change anything?
Algebra.
It's just me stating my answer.
I did it here at the top.
I just know it said it was more awkward, so is it just because it's awkward because you have to write it? Or does it
It's-
change anything as we go on?
No, it does not change anything.
Oh, okay.
It's just- It's awkward how you write it and use it.
Fair enough.
Okay. Moving along. Okay. And I can't wait. Is it in lesson 3? It's either in lesson 3 or lesson 4. I get to start teaching you shortcuts. To where I can say, here's the function, what's the derivative, and there's no work to show. That will happen one of these days. But in the meantime, we gotta learn the definition, which is why we start off this way. Okay, given y equals x squared minus x, use the definition of derivative to find f prime of x. It's just practicing. So f prime of x, I'm going to use the limit as h approaches 0 of
Didn't give me enough room in this box. Oh, shoot.
go sideways. Okay, f of x plus h. So it's going to be x plus h squared minus the quantity x plus h. There's f of x plus h, yes? Minus f of x, which is minusing the quantity of x squared minus x. All over h. Okay. The limit as h approaches 0 of okay. I wrote mine out as x squared plus 2xh plus h squared minus x minus h minus x squared plus x. Sorry, I dropped off talking because I thought, you know what? You guys can do this too, right?
I'm convinced that I can just factor in my sleep.
X squared and x squared are gone.
Let's be realistic.
Minus x plus x are gone.
I don't even factor in I just know what it is now.
Literally.
Are we talking about the foiling?
Just write it
Yes.
Are you talking about the foiling?
Yes.
And that's
Yeah,
good.
You just know what it is now.
Because
so
here's the deal.
X plus
In
X
algebra
squared,
2, I would have never dared have you guys foil that without showing it.
Mhm.
Now, granted, you guys are the ones that probably could have done it in algebra 2 without seeing it, but I would have never dared do that. Here, I'm going to force you to do it. Now, and when I do that, does that mean you can't write the FOIL out on your paper? No, it doesn't. You can, if you're having issues, if you're making mistakes, by all means, write the FOIL out, guys. But I'm also showing you it's okay not to.
I think in the hallway I'm going to go ask Patrick what x plus h quantity squared is and just see what he says.
Cube is the one that I still have trouble with.
Okay. Now, if you want, here's the step I wasn't taking. If I go ahead and factor h out of what remains, then I have what?
2x plus h minus.
Did you guys get the -1?
That's
Yes.
easier than I thought it was.
Okay. Now, so if you want to, I guess I should just show that step right there, because that's really, I just don't want anyone to get lost in the cleanup.
Cancel the h's.
The limit as h approaches 0 of 2x plus h minus 1 is equal to what?
2x minus 1.
Because as h approaches 0, it goes to 0. Okay. So we know that f prime of x is equal to 2x minus 1.
Can this just be the entire lesson?
Okay. Now, I have written in my notes, general form of slope of the tangent line. Okay, and I think this was just kind of a, remember, when we're doing something like this, here's your equation. Slope of the tangent line is 2x minus 1. That is any place on the curve, this is slope of the tangent line. If we're talking about, okay, well, what about when x equals 5? What do you do to actually find the slope? You're plugging it in, right? So just kind of realize that this is This is your general form of slope of the tangent line. Okay. Okay. Now, you've kind of got the basic form of the derivative down. And the idea where we were right here is it's good to be able to look at like what they might give you here. This is a problem you might see like in a multiple choice AP, is what is the limit of this right here? Now, we can do this a long way, but then there will be a short way eventually too. And that's what they kind of are pushing you for. But the idea to recognize, oh, this is f of x plus h minus f of x. So my original function is something squared minus something, so x squared minus x. That will be a skill you'll want to gather later, I guess I should say. Now, alternate forms of the derivative. Okay, the derivative, definition of derivative has, I don't know, 3-4 different forms. So numeric value of the derivative at a point x equals a is also found by these. So f prime of a, slope of the tangent line, limit as h approaches 0 of f of a plus h minus f of a over h. This is what we just did, isn't it? Except this is saying if you want to find it at a specific point, you can go ahead and put the a value in. Kind of like what we did in homework, yes? You guys had good homework questions because that's what we did when we plugged the 9 in, wasn't it? Mm-hmm. Or this is our another alternate form of the derivative. It's different. The derivative, again, this is what a point is. Notice this one is the limit as x approaches a. Is that supposed to be a there? Yes, okay. Of f of x minus f of a over x minus a. So this is another alternate form of the derivative. Okay, good one to know in addition to knowing this one right here. They both work. Again, I feel like a big place we see them is when doing limits. Hey, find this limit. Again, if you can recognize this definition of derivative, it'll be much easier to find that limit. Okay, use the alternate form of the derivative to find f prime of a for f of x equals square root of 3x plus 1 at a equals 1. So when we talk about the alternate form of the derivative, we've done that one. We're going to practice with this one. Yeah, we need to do this one, okay? I don't know why she has this listed as alternate form of the derivative because this is just definition of derivative with the a plugged in. This is an alternate form of the derivative because it's a different equation, right? So, okay, with that in mind, we were told a is 1, yes?
Yep. A wants it.
So if a is 1, what is the function value when a is 1? In other words, what is f of 1?
The square root of 3 times 1 plus 1.
Yes? F of 1 is square root of 3 times 1 plus 1. Just plug it in here, which is 2. So we have the fact that f of 1 equals 2, which is probably, that looks like that's how I have it written in my notes. Realizing that's the same thing as saying the ordered pair, and here, you need to recognize this is the same thing as saying the ordered pair, 1, 2, yes? Mm-hmm. More important to me, though, is that you can recognize f of 1 equals 2, because how are they going to give you information in calculus? They're going to give it this way. They're not going to tell you 1, 2. They're going to say f of 1 equals 2. Okay, so we're being asked to find f prime of a when a equals 1. Why? Yeah, I don't even know why I wrote f. In my notes, I've written f prime of a the first time through, but I went ahead and plugged in 1, didn't I? Yes. Okay, so f prime of 1 is what we're doing, right? Because they told us that a is 1. So, f of x means f of x. What is f of x? That is the square root of 3x plus 1 minus f of a, right? Because f of a is f of 1, which is 2, all over x minus a, and a is
No, 1.
1.
Oh, because
Oh, that was a little.
Are we there?
yes.
Yes.
Okay. I mean, if I put in a little, okay, this was f of x, right? Minus f of 1 over, well, do I really need to say x minus 1? Are we there? Okay. Now, we gotta clean this fun thing up. Oh, gosh darn it.
Very good limit.
Thank you. Now you tell me, Doug.
Shoot.
You could have saved us all, Doug.
Dang it.
Oh, I did.
Well, I'm glad some of you did. However, okay, so what should I have put here?
Limit is x approaches 1.
The limit as x approaches a, which in our case is 1. I am not being a very good example the last couple of days. I'm normally a better example than this.
It's just so easy to forget.
It is, and I'm proving that point, unfortunately. Don't use me as an excuse. Okay, guys, how do I deal with this fun little thing?
X plus 1 and x plus 1.
No.
What?
No, the square root of x plus 1.
Like what we did in homework. Conjugate of the top. Square root of 3x plus 1
Yeah.
plus 2 over square root of 3x plus 1 plus 2. Because the problem we have, if I put in 1 right now, you're going to get 0 over 0. I didn't demonstrate that because I'm running out of time, but you would get 0 over 0. So this is the limit. Sorry, annoyed with myself, honestly, okay? As x approaches 1 on top. We're foiling, but square root of 3x plus 1 times square root of 3x plus 1.
3x plus 1.
Outsides and insides, poof. Minus 2 times 2 is 4. Denominator, oof. Ugly,
Yes.
but
Do we FOIL it out?
no. Leave it as x minus 1 times square root of 3x plus 1 plus 2. Clean up that numerator. What's that numerator become?
3x plus
3x minus 3.
minus 3.
Plus
Okay, 3x minus 3 when you clean up the top. The bottom, I'm just rewriting. X minus 1 times square root of 3x plus 1 plus 2.
Factor out 3.
Okay, I was going to say, come on, smart cookies. What do you notice about the top? There's a GCF of 3. Leaves me with x minus 1. Oh, coincidence?
I think not.
Exactly. Denominator is the x minus 1, the square root of 3x plus 1 plus 2. So, those x minus 1s will cancel. We're doing the limit as x approaches 1 of 3 over the square root of 3x plus 1 plus 2. And to do that limit, we plug in, yes?
Yep.
So 3 over the square root of 3 times 1 plus 2.
3 over 3 over 4.
I was going to say,
I was like, okay, my quick math gave me 3 over 4. I wasn't looking at the answer key. Okay, so what is this? F prime of 1 is equal to 3/4. So that's a really long way to say the slope of the function at when x equals 1 is 3/4. Sorry, I know I sped that up at the end, but I didn't want to get caught in the middle of this problem. That would be ugly. Okay, we will pick up there tomorrow. There's a few things to talk about at the bottom of that page, and then we'll go from there. Ooh, we have a lot to do. Might bring a red and blue colored pencil if you want tomorrow. Or we'll dip into my colors and
Probably won't, so.
yeah.
We'll just dip into your color.
Yeah. We've